Scott Hunter on DevOps capabilities in Azure.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Hello. I'm your host, Jeffrey Palermo. You can go to www.azuredevops.show to see past shows and show notes. Our guest today is none other than Scott Hunter, Director of Program Management for .NET at Microsoft. And Scott, you and I have known each other for over a decade, but my times have changed just in that period of time. But welcome to the show, sir.
Yeah, thanks. I don't think I've ever been on the show before, actually, which is weird because we've known each other for that long.
Well, that's because the show hasn't existed for that long.
You've been doing something for all these years, though. So
Right. So I think, Azure came out, and all the listeners on this show are targeting and putting software in Azure. But Azure came around, what was the first year? 2006, 5, something like that?
It came out in 2006, I believe, but it wasn't very good back then. I think of Azure from the lens that I came through, which is we had just shipped .NET Framework 4, and we had shipped Visual Studio 2010, I believe. And right after that, Scott Guthrie, who is the EVP that's responsible for the group at Microsoft that runs Azure, he left Developer Division. And when he did, he left Developer Division to go work on Azure. And when he did, he took any of the parts of Developer Division that had web or cloud related stuff with him. So at the time, you and I kind of knew each other from the MVC days in ASP.NET. And when this transition happened, Scott basically took the web tooling team, he took the ASP.NET team, and he took the team that made IIS. So all three of our teams were lifted out of Developer Division, and we went to a new business org that Scott ran. And our goal was to basically make Azure awesome.
So just so that people who maybe they've listened to you on at conferences or online shows or whatnot, can you give an overview of what your team actually builds? Because it's quite a bit. Yeah.
So when I joined Microsoft back in the era we were just discussing, I came into Microsoft around 2007, and I was working on the ASP.NET team. Today, I'm the Director of Program Management for .NET, and that is the entire platform. So .NET is basically .NET Framework, it's .NET Core, it's the ASP.NET and the Entity Framework stacks that live on top of those frameworks. We also build the managed languages, so that's C#, VB, and F#. We build all the tooling in Visual Studio around .NET. So if you're seeing IntelliSense in Visual Studio, you're refactoring in Visual Studio in .NET code, we build all of that. And then finally, one more of the pieces that we lifted out when Scott moved to Azure, my team also builds the web tools for Visual Studio. So, the HTML, CSS, JavaScript editors, and the various ways that they work with .NET, all the publishing experiences to let you publish to DevOps or publish to app service or containers or container registry, that all comes out of our team.
Yeah, that's a huge scope. So for sometime this year, all the conversation is around .NET Core 3 and what's coming out. But there's a lot of customers that we have, and I think a lot of people are wondering, what is that? When should I move to .NET Core for people on .NET Framework, and what's the difference? And I can see how people will be confused, but is there a way we can simplify it for them?
I'd love to try to simplify for people. There's two pieces of the story that are kind of interesting. Is so we started thinking of .NET Core around 2014. That was the time frame. So 4 to 5 years ago was when .NET Core started coming into some notion of being around. And what really drove it was we were looking at we always, as a team, the ASP.NET team, we always were looking at where is web technology going? What's the future direction of web? And so, you were part of the earlier efforts when we were moving from web forms to MVC. As we saw that style of writing web applications more popular. Then we saw that people needed APIs, and so we built Web API. And then there was people who wanted to do real-time messaging to a large number of devices. That was when SignalR came into play. But in 2014, what we were seeing were some trends, and the trends were companies were telling us if the technology they were using was not open source, they were not going to use it. They also told us our data center could be Windows, it could be Linux, it's a cloud, and we won't choose a technology that doesn't work on all those. And so, as a team, we started thinking, man, we need to go and make ourselves a fully open source .NET and a fully cross-platform .NET, and that was the original envisioning of Core. And when we first built that first core, it was the Core 1.0. I don't think even we had thought through how big it was going to be and how it was going to change the platform. Originally, our goal was not to make it compatible with .NET Framework necessarily, but once we built it and people started using it, there was a huge cry that I really want to move more of my .NET works, my .NET code to Core. And so with Core 2, we added a ton of APIs back. We created something called .NET Standard, which is a spec. Every .NET, whether it's Mono, .NET Framework, or .NET Core, they all have to support all the APIs that are in .NET Standard. And that made it easy for a customer to share code from a Xamarin app into a Core app, or a Core app into a Framework app. So that was sort of in the Core 2 wave of trying to make Core more palatable to a larger audience. With Core 3, which we announced in early December, that goes kind of to the fruition of the edge, which is .NET Core 1 and 2 primarily were for web workloads. But a lot of folks don't recognize that even today, we have over 1.5 million developers every month in Visual Studio building desktop applications with WinForms and WPF.
That's a lot.
I mean, even though I'm a web guy, those are great numbers. Those have a lot of customers. And so we announced .NET Core 3 in early December, and we said we're going to move WinForms and WPF to Core. So at that point, we have most of the big pieces of .NET Framework have moved to Core. The ASP.NET workloads, the MDD Framework workloads, the WinForms and WPF workloads. There's an open source. We make all the source open for the .NET Framework. And so in the community, a guy named Dustin has actually taken Windows Workflow and has a version of it that is an open source project that runs on top of Core. And so all the pieces are slowly getting there. There was another reason why we did Core as well. And it's the hardest one to explain to customers, which is, .NET Framework's been around for 18 years. It's awesome. But one of the challenges we have with .NET Framework is it is a component of the Windows operating system. And what I mean by that is my team can't decide when we ship a new .NET Framework. .NET Framework ships when Windows ships. Windows also has a super high compatibility bar. And that compatibility bar, they don't want to have a new Windows update break somebody's applications. So we found ourselves also around 2014 at a point where to really take .NET further, we needed to add new APIs and change some of the APIs that were there. But I can't change any APIs or change any behavior of anything in .NET Framework because doing so would be a breaking change to Windows. I can't ship .NET Framework faster because it's a piece of Windows. People need to realize .NET Framework is installed on over 1.1 billion machines today. So just think about that. If you make a change in some code and it gets blasted out to 1.1 billion machines, the odds of you not breaking somebody are
right.
Yeah, it's not good. So one of the other core tenets of .NET Core was to be independent of the operating system. So it's not part of Windows by design, and it supports what we call fully side by side. So I can have 8 versions of .NET Core on my machine at the same time. Windows Update doesn't touch .NET Core, So you don't have to worry about Patch Tuesdays, breaking your applications. As a customer, it's your choice when you decide to take the new version of .NET Core. If there's a security issue, you have to decide to go and put the new version of Core on the machine. This is no different than what you would do with Java or Node or Go or Python or any other technologies. So maybe customers will feel a little uncomfortable that we don't automatically patch them, but it means your applications won't break. So for us is really a reimagining of .NET that is, for the most part, fully open. It's all open source, even WinForms and WPF. Cross-platform, except the pieces that can't be. WinForms and WPF are Windows technologies. They can't be cross-platform. And it's completely side-by-side. So you control when it's on, what versions are on the machine, when they're updated. In fact, we didn't even talk this. You can actually include Core as part of your application. So if you want to, you can put an ASP.NET Core application on a machine. It doesn't even have .NET Core installed on the machine. You just zip the folder up and run your application, and it runs its own self-contained version of Core. So for all the developers out there, maybe you want to use the latest feature of C# or the latest feature of .NET. And today you have to go and talk to your team and say, hey, when are we going to put the new version of Windows on a machine, or when are we going to put a version of a framework on the machine? .NET Core removes all those barriers. Now you can have one app running on .NET Core 1.0, and you can have the next app running on .NET Core 3.0 on the same box with no conflicts between the two frameworks. And so it solves a lot of problems that we could not solve with .NET Framework. I want to say one more thing, which is you asked, how should we think of these things moving forward? The way I think of these things is we will have brought most of the big workloads as we ship .NET Core 3 later this year. And I think once that version ships, that's a good time for any .NET developer. I would say any app you're building, you should be building it on .NET Core for all the reasons that we just talked about, all the benefits you're going to get by running on .NET Core. .NET Core will get new features that will not be in .NET Framework for the same reasons we described. I can't change System I/O in .NET Framework without risk of breaking something. In .NET Core, I can add new APIs. So the two frameworks will slowly diverge, with Core taking on more features. But at the same time, nobody should be freaked out about .NET Framework. It's not going to go away. And quote the hell out of me on that. We're not going. It is a part of Windows. It's part of Windows compatibility. It will always be there. In fact, even though it's going to move slower, .NET Framework 4.8 will come out a little later this year, and it's got new improvements for high DPI, accessibility in WinForms and WPF. There's hundreds of bug fixes in it, so we're not leaving that behind. It's just it's going to move slower. You're safe to have your apps on top of it. Core's going to move faster. It's going to get newer APIs.
And there's how many applications on .NET Framework? I don't even know the numbers, but it's
millions.
Huge. And you mentioned .NET Standard, which for a lot of our projects and a lot of our clients, that is so key because everyone wants to trend towards the later and the newer versions and technologies, and that bridge is so key. I think with .NET Core 2, if we could get the application up to .NET 4.6.1, I believe, then it bridges over with .NET Standard. And for example, it was super easy. We upgraded one .NET Framework application that used in Hibernate, and we upgraded it to Entity Framework Core 2. That was just swapping out the data access library and essentially compiling it. It would still run on .NET Framework, but it's using Entity Framework Core. And just having .NET Standard as a bridge between the two, I think opens up so many possibilities.
Yeah, I tell customers today that if you're even on your .NET Framework applications, start making your class libraries .NET Standard class libraries. That will just start preparing you for the future, where when you want to move that code to Core, you've already one of the things that .NET Standard does for you is it puts some rails on, and it tells you if you're actually using stuff that's not in the standard, which means, hey, I might not have portability to Xamarin. I might not have portability to .NET Core. But I would tell all customers to start trying to move all their class libraries to .NET Standard. .NET Standard runs on top of .NET Framework, so you don't have to move to Core, but it just starts heading you in the direction where you'll be more prepared when it comes.
That's actually a really good rule of thumb, because we've all heard we don't want to mix our business logic with UI and data access and other tangential concerns. And that puts some real guardrails where the compiler helps us. If your business logic can be in a library with .NET Standard, then the compiler is going to help you realize, oh, wait a minute, I stuck a dependency right in the middle of my business logic.
We also have a cool analyzer, and I'll send you a link to the analyzer. I'll find it in a second and send you a link to it. And what it will do is it will actually go a step further. It actually looks at your application in real time, and it will tell you if you wrote some code that will not run cross-platform.
Oh, nice.
So it'll say this code won't run on a Mac, or it won't run on Linux. And so it's pretty cool from the standpoint. Like in many cases, I was recently porting a WinForm application from .NET Framework to .NET Core, and it was telling me that registry doesn't work on the Mac or Linux. In my case, it's a Windows app, so I don't care. Mm-hmm. But it's kind of cool having the tool tell me in real time, where I'm at. So I kind of know, hey, if I'm ever thinking of moving this code to cross-platform, here's the gotchas that might be here.
Okay. So .NET Core is coming out later this year. So many people...
Core 3.
.NET Core 3, you're right. So many people are talking about single-page applications, and React and Angular get a lot of talk time, and then people wonder, what's the .NET story there? Can you give us an update on Blazor?
Yeah, that's... for people that don't know, Blazor is an interesting project. It's about a year and a half ago, I think, Steve Sanderson on our team was at NDC London, and he was trying to come up with some cool demo. And something called WebAssembly was in the news at the time, and Steve went and cobbled together some stuff to get WebAssembly working with .NET. And for folks that don't know, WebAssembly is I think one of the coolest innovations in browser technology I've seen in a long time. What WebAssembly is it's a type of IL that you can compile to, and you can basically run any language in the browser. Right now, our browsers primarily just run JavaScript, but with WebAssembly, you can run C++, you can run C#, you can run Go, all these. So suddenly, the browser opens up to all these language possibilities. And when I say this, I'm sure there's people on the podcast going, "Oh my God, this sounds like a disaster." We all remember ActiveX. We all remember Silverlight. We all remember Flash. We remember the Java plugin, and all the problems those things had. WebAssembly actually solves the biggest problem we had with those. All of those technologies, the reason those plugins were bad was they had full access to your computer. A Flash app can see your camera, can see your mic, it can see your hard drive. The same thing goes for the Java plugins and ActiveX. And so there's a whole bunch of security stuff around those things. The cool thing about WebAssembly is it runs in the context of the browser, which means none of the code that runs in WebAssembly has access to your registry or your cameras or your file system. It basically has, nothing more than the browser, which means you can feel safe that the code running in there is running in a nice tight sandbox and can't get out and touch your machine. The other cool thing about WebAssembly is it works, anybody can make a language compile to it. So I think you're going to see over time a wide array of languages support this. But what we did with WebAssembly is we said, wouldn't it be interesting if we could run C# in the client? And I'm not trying to, our team's goal is not to go become a replacement for Angular or React or Vue. If you're using those frameworks and you like them, then good for you. In fact, we have templates inside of Visual Studio to do those types of applications with .NET Core today, and we'll continue to do that. But where WebAssembly comes in as being kind of cool is if you don't want to write JavaScript, you can now write C# in the client of the application. And so this provides an amazing array of crazy ideas. Maybe you've got a WinForm application. One of the apps I ported recently was a WinForm game that I had running in the browser in like an hour or two with Blazor. And so one of the cool things about Blazor is when we first announced it, it was an experiment. And I'm happy to announce with .NET Core 3, we're taking Blazor and we're going to build it into .NET Framework or .NET Core. So it'll be part of .NET Core. We renamed it to something called Razor Components. It'll ship as part of .NET Core 3. And in that time frame, it'll actually not run. You'll have the option of running either in the client using WebAssembly or we can also run your code on the server and use SignalR to actually send the deltas between the UI updates across the wire. But what this lets you do is it actually lets you build a modern spa feeling app, which means the pages don't refresh as you click stuff. It just updates in real time, all in the browser. But you don't have to use Angular, React, or Vue. Those things move at a torrentially fast rate. Some of those things major versioning 2 or 3 times a year. You're going to get the stability of .NET. You're going to be able to share the same C# code on the server and the client. You're going to get that strongly typed aspect of .NET to make sure that you're going to know at compile time whether it's going to work and hook up. And you get all those benefits of one of those SPA frameworks. And so I think it's super exciting technology that customers are just going to love. Every time I show it to somebody, it blows their mind.
Are you saying that both options are going to be available with the .NET Core 3 release?
.NET Core 3 will ship with the option to run the code on the server, being the option that's in the box, and we'll have an add-on where you can actually get the WebAssembly stuff to run it on the client, and I can explain why. The biggest challenge on WebAssembly is we basically have to take your .NET code and we have to compile it down into WASM. The technology that we're using for that today is we're using Mono. So, for people that don't know, Mono is an open source, community-driven version of .NET framework that the Xamarin technology builds on top of. And they have some better technology in the area of what we call ahead-of-time compile. Ahead-of-time compile is when you pre-compile the application into like native code. And so they are a little ahead of us in the .NET space in being able to do that. So we're using their technology. We don't think we can have it at a RTM level of quality in the time frame of shipping .NET Core 3, but we are working on it. So that I can say that we are committed to that, and we're working on it. We want that technology for other reasons. Imagine a world beyond .NET Core 3 where you can take your WinForm application and compile it to a native executable. You can take your ASP.NET Core application, compile it to a native executable. Take your service, compile it to a native executable. Those native executables would run on Windows, Mac, and Linux. So you're going to see us take this AOT tech way beyond WebAssembly. We want to give you the ability to run any of your .NET apps in native performance with no framework on the machine, because the framework is compiled into the application natively. So WebAssembly is just the tip of the iceberg there.
That blows my mind. And even as the web has kind of consumed all application types, it seems like, or at least that people talk about, I think the mobile explosion has shown that people don't really care about having a web application. They just want one that runs well and kind of feels snappy. And so even though you could have a mobile website on your iPhone, if there's a native application for, most of the time you're going to use it. So if you have the native experience and it's snappy and stateful and you can get the job done, you want to get in and get out.
Yeah. So, I mean, that's, I kind of jumped over that as well. So that means when you're running C# in the browser on top of WebAssembly, you're going to be near native speed. You're going to be within a few percent of running a C++ app native on the box. So as you said, it's going to give you that really native-y feel. And as you said, in the mobile space, I think we all prefer to have a native app over a web app. It's the web's fast, but the web's not gotten fast enough yet to make it, every time that anybody tries to force you to use a mobile-y web thing, you kind of go, man, some of these other apps are a little better. The other thing about the native apps, the complexity level of building a SPA app versus building a WinForm app, they're on different scales. WinForms is still probably my favorite technology for building quick desktop apps or quick native apps because it's just so damn simple. And I don't have to know HTML and CSS and JavaScript and a JavaScript framework and TypeScript and Webpack and all the things to crunch a SPA app together. So there is that appeal. That's also I think we think that's an appeal for Blazor as well. It doesn't, because it's giving you a native app in many cases. You don't have to use all those string all those technologies together.
It's a lot of layers.
It is. And I'm not, as I said, people that love that stuff continue to love it. But our job is honestly to give customers options, whether that option is to write a SPA app with a .NET backend, or write a Blazor app that's native both ways, or a desktop app. Our job is to give you all those options.
The Azure DevOps Podcast is sponsored by ClearMeasure, a software engineering firm and Microsoft Gold partner, empowering development teams to be their best. ClearMeasure equips developers with the DevOps tools, methods, and automation necessary to focus on building their applications, rather than wrestling with builds, deployments, or environments. Click clear-measure.com to see whether a DevOps implementation is for you.
And you're right about WinForms. I built some pretty significant and large WinForms applications, but the rate of development was just so fast. And I think there's a few concepts that are different between the JavaScript SPA ecosystem on top of a server side versus a like native WinForms or WPF app. If you have .NET on the back end and then on top of SQL Server or some data storage, but then on the front end you have the JavaScript, Angular, React, you have different package management systems. You have different ecosystem of libraries. The language difference is what it's easy to talk about, but you're in a completely different environment world, maybe a different IDE that's most appropriate. Whereas when you have the same language and the same package management and the same library ecosystem for the entire application, I think that's what makes Xamarin Forms so powerful.
Yeah.
Is it brings cohesiveness to all of the layers of the system.
I agree 100%. That it's funny when we go and talk to customers, we'll find a lot of customers that actually have two separate teams. They have one team that builds the back end, one team that builds the front end. In those cases, those teams you'll typically find they actually have different techs on both sides.
Yeah, they'll
have .NET or Java on the back end, and they'll have one of the JavaScript frameworks on the front end. And for them, that's okay because those are separate teams. You get into different companies, typically smaller companies. One team builds the front end and the back end all together. And that's when, as you said, having the cohesiveness of the same technology on both the front and the back really helps, because it would be weird to be doing, half your job in one language, half the job in the other language, and then two different completely separate tool chains, as you said as well. And that's what we think makes Blazor awesome is the fact that you get a cohesive tool chain, the same tool chain that you would build any .NET app, both to build the client and to build the back end. Okay,
before we leave Blazor, because this is very different runtime here, are we still deploying as an Azure website, or does this have any changes to our actual deployment configuration in Azure?
It has no changes to the actual configuration for Azure. You could put a Blazor app in Azure App Service. You could put it into an Azure App Service container. You could put it into AKS, Azure Kubernetes Service. It doesn't really matter. It's just a web app. It's just files that are served by a server.
Cool. Is it mandatory to use the SignalR service, or is that just kind of baked in with the framework behind the scenes?
It's baked in with the framework, and so the SignalR, what you're going to have the option to do with when you decide to write code in a Blazor world. We haven't put this into the Razor components spec yet, but you'll have some ability to say whether you want that to run on the client or the server. So let me explain where SignalR comes to play into this. Imagine I've got some HTML on the page and I've got a button on the page, and when you click the button, today maybe you have some JavaScript that runs that changes the text. And now in this case, because we're going to use Blazor, you're going to write some C# code that's going to go change the text in that label. So, what happens in the JavaScript case? The JavaScript runs on the client and it goes and changes the text. And so the text just changes in real time. If you're running Blazor and you're running WebAssembly, exact same mechanism would happen. You touch the button and we go and touch the DOM on the client and it updates in real time. If you're running the server-side version of Blazor, what would actually happen is when you click the button, the command would send a signal to the server, The server would make the change of the text, figure out the delta between what the text is now and what it's going to be in the future, and then use SignalR to blast that back across the wire to the client, and then the client takes that delta and blasts it into the DOM. Now, the cool thing about being able to run client or server, I was saying before, one of the things about WebAssembly is when you're in WebAssembly, you are in the sandbox of the browser, which means you can't touch the file system, you can't run threads and other stuff. Well, you could say part of the app, you go, I want that to run on the server, because by making that piece run on the server, it can actually touch the file system and load files off the disk and whatnot. So it's kind of cool. You get the choice of where you want to run the code.
Yeah, I think it's going to be game changing. I'm really looking forward to using it in some specific cases. With so many options in the .NET ecosystem, the appropriate architecture comes into play, and questions about, hey, what architecture should we choose? I think back 2002, there was a .NET Pet Shop reference architecture that was an example. Of course, anybody puts out any type of architecture, everybody else chews it up and spits it out because there's no one size fits all. But in the spectrum of monolith versus microservices, where's this all landing?
Yeah, that's a funny question. We ask ourselves this question all the time, because the terms, I'm sure you guys hear the terms as much as we hear them. Microservice is a popular term today. Container is a popular term today. What I find something funny when I go talk to a customer, they go, yeah, we want to move to microservices. That's not really what they want to do. What I find out when I talk to them is they're like, we have this huge monolithic application, and it's very difficult to build it and push it out to the system. And so our hope is maybe if we cut this application in half, or maybe cut it into 3 pieces, well, then we can have a different team working on each of the 3 pieces, and they can all rev independently and version independently. That's what I find when I go talk to most of my customers. They don't want to go take their app and break it into 100 pieces, for example. Mm-hmm. We actually have speaking of architecture, we have a new app, not Pet Shop anymore. Now it's eShop Containers, or eShop. And if you go to dot.net/architecture, we actually have an architecture guide about how to build microservices on .NET Core in Azure. Deploying all the pieces, into app service and Kubernetes and all the variety of tech that we have in Azure. That said, we do think that our current .NET offerings are a little UI heavy. When you think of ASP.NET today, you probably think of UI. You think that MVC is going to be there. Even though we have a SignalR and a Web API and some other stuff, I think there's a connotation that ASP.NET is UI technology. And so you're going to see us offer some new ways of building applications. We haven't shown these publicly yet, but there are going to be things like background worker or service worker. Sometimes another rep that ASP.NET gets sometimes is it's heavy and complicated. And it's not really. It's just we give you these templates with a bunch of options and a bunch of stuff turned on by default. We're thinking of having more of a grow-up model where you can say, I want to do a worker. And a worker might be something that listens on a queue. And so we're going to give you a really cool way of going file new, I want a worker. And maybe that app basically contains nothing other than a piece of code to run. And then you right click and say, I want this code to run when a message goes into service bus. And we'll wire that together, and your app still is about 4 or 5 lines of code. Just it's here's the handler for the event when the event comes through. And maybe you then say, hey, I need some logging. And so we'll put an iLogger in there. Maybe you want some configuration. So we'll drop some configuration in there. We want to make building .NET applications feel more like you don't have to start with some big monolithic template that we have. And you can decide to just add things piecemeal by piecemeal. Because if you look at a default Node app, which in itself is not very useful, it looks a lot simpler than a default ASP.NET app. Mm-hmm. And so we're trying to figure a good way to break that divide. If you read that book I was talking about, the architecture guide on doing microservices with .NET Core, you'll see that a lot of the microservices are written without using controller folders and all the stuff that we have in ASP.NET. So we're going to give you more of a graduated path of, if you want small and simple with not a lot of tech, we'll give you that. And you can just opt into each piece as you go. And so you'll hopefully see some of this in the 3.0 wave.
Awesome. Yeah, there's some really good capabilities in Azure for running essentially headless background jobs that just process data off of a queue or whatnot. Azure Functions is
yes.
Azure Batch doesn't get a whole lot of talk time, but there's plenty of good options.
Lots of good options, and we want to make those options. Like, let's say you do Azure Functions today. It's awesome, but there are some negatives to it, and the negatives are because you're not really using a framework. It means that you're going to parse the URI. You're going to break the components out yourself. If you're using ASP.NET Web API, the framework could do that for you. If you want to return some data, you're going to have to serialize and do all that serialization yourself in Functions. Imagine if we gave you something where you could get all the benefits of an MVC. You get your binding, your model bindings, where the parameters come in. You get automatic encoding on the way out. We'd like to give some of those experiences to customers where you get a richer function experience.
Well, that would be really useful. And I think the two channels are the first one that comes to my mind is the synchronous channel, and that's HTTP web service. Synchronous blocking, I'm not going to go on until you give me something back. And then the other would be asynchronous, Azure Service Bus, but model binding and mapping, all the same things apply, but you could have a unified programming model, whether it's coming off of a queue or coming synchronously over the web.
Exactly. I mean, in a perfect world for us, we'd love to say you write some .NET code and you can choose where to host it. If you want to run it as a function, you can run it as a function. If you want to run it as an app service, you can run it as an app service. And there's pros and cons. And, if you're if you listen to the podcast, functions are great for things where the code doesn't run often. Mm-hmm. And you get you get a cheaper price for something that runs 50 times a day or 100 times a day. But if something's going to run all day, you're better off doing something like app service. So you need to know those dials today. But functions is best meant for, hey, it's going to take X number of hits a day, or when something hits a queue or something like that.
Right. All right. So how do you want to do this book teaser?
Yeah, so let's just talk. I was actually in your area, I think last summer.
It was May, I think.
May of conference. And Jeffrey and I were sitting down talking about, I was frustrated because we have all these awesome DevOps features in Azure. Azure DevOps, pipelines, there's a whole bunch of stuff I'm sure you guys talk about on the podcast. And we have a bunch of awesome .NET technology. But I don't think anywhere we've ever explained to a customer how to, the way I think of this is, hey, I'm sitting here at my computer, I'm going to write some code, I'm just goofing around. And then maybe I'm onto something. So I called Jeffrey up and I'm like, hey, I want you to look at this too. So the next step is I need to put this in Git. I need to put it in GitHub, and now we can share code. And before I was right-click publishing, but now I need to publish using CI/CD. So I want some of that. And now we've got something real. We got staging in production. We're using CI/CD. But now the app's running in production. Well, how do I know if the app's healthy? What technology am I using to look at that? And we just had a conversation about nothing tells you how to start from nothing and then go all the way through what I would call the application lifecycle of running an app in Azure. And so I was proposing to you that maybe we do a book in this space.
And that was very congruent with my vision and the challenges that I see, because there's so many options out there, and most of the developers that we work with in our consulting practice are not poring over every book that comes out, every blog post, every podcast, and they're just heads down trying to do good work and serve their business and keep the software stable and build new applications. And so when they come up with a new major module or a new application that needs to be built, they have to ask themselves the question, okay, out of all of these options, which ones am I going to pick, and how do I put them together? And what is the 80-20 rule? What are the rules of thumb? And in a lot of cases, they're users are users in their own company. Their application is not going to be Twitter scale. And so they can, they don't have to worry about those types of things. They're just what are called regular applications, but thousands and thousands of these development teams are just making regular applications. But by and large, most of them are going to have a website of some sort, web API, MVC, web pages, something on the web. They're going to use SQL Server, and they're going to have plenty of business logic. And so you think about it and you think, okay, you have a website, you have a back-end job, Windows service of some type, and you have a SQL Server database. Man, just that architecture covers this huge swath of possible application types. But even with that, as a rule of thumb, just kind of as a Visual Studio solution structure, what should they do? How should they put it into source control? And of course, Git is really the de facto standard. So we need to just show them that. How about branching strategy? What about private build? What about continuous integration build? What are the three normal now levels of automated testing suites and how to hook those up? How do I package the different deployable components of my application? How do I put together this deployment pipeline? And what are all the technologies and tools and how to stitch them together? And it's just a lot of stuff. And so we're writing a book, and we're calling it .NET DevOps for Azure. We thought very simple title, just .NET DevOps for Azure. And it's that if you are writing an application in Visual Studio and you're targeting to run it on Azure, it's just the go ahead and do it this way book. And if you're an expert in any one of the particular areas, you could find probably 5 other ways to do it that would also work. But if you don't know of another way and you just want to be told, hey, just do it this way and know that you're going to fall into the pit of success, that's the book for you.
Yeah, I am super excited about this book, and the hope is that this book will be ready right around the time of Build this year, and hopefully we'll have you actually out at Build to actually do a talk on the book.
It's on my schedule.
I don't know if you noticed, but Build's a little different this year.
Yes.
The Build conference this year has calls for community to reach out and submit their own papers for talks.
Mm-hmm. Yeah.
So I think it'd be fun to have a talk where you and I do a talk together on the book and .NET and Azure.
Yeah, I'm looking forward to it and working hard on the book, hustling. Just going to have a few more months to crank it out, but it'll happen.
May's a long ways away.
Oh yeah. Well, awesome. Well, Scott, before we go, is there anything else our listeners should follow up on or resources they should take a look at?
Big thing I would always tell users is go to dot.net. That's our website. There's tons of stuff we didn't get to today. We have an awesome machine learning library called ML.net that exists for .NET. You can grab the .NET Core 3.0 previews there. And there's a whole bunch of, as I said before, there's an architecture section where there's a bunch of ebooks and full running samples showing you what a modern container-based application running in Azure would look like on .NET Core. So there's a lot of great materials there. Just go to dot.net and check out, all the different techs you can build on top of .NET.
Awesome. Well, thanks so much, Scott, for visiting with me.
Yeah, thank you.
And until next week, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.